My name is Olajide Ademola Sunday, a Module 2 Direct Entry student of Mathematics Education Department. Today I shall be taking us how to apply sort to finding the trigonometric ratios. When we talk about sort includes irrational numbers such as root 2, root 3, and the likes. And today we shall limit our angles to special angles such as 30, 45, and 60 degrees. First, let's look at 30, 60, 90-degree triangle. And we obtain that from this equilateral triangle. We find the height, which is the line of symmetry there. We obtain root 3, and from there we can use this to obtain exact values for the trigonometry of these angles. For example, if we say we want to find tan 30 degrees, we come here, it is opposite over adjacent, that is 1 over root 3. And when we rationalize 1 over root 3, because the denominator is an irrational number, we multiply it by root 3 over root 3. Root 3 over root 3 is like we are multiplying the entire of this fraction as we are multiplying it by 1. So that's going to give us root 3 over 3, because root 3 times root 3 is root 9, which is 3. So here we have root 3 over 3. If we also want to find maybe sine 60, for example, sine 60. Sine 60, 60 is the sine is opposite over hypotenuse. That will be root 3 over 3. Over 2. Root 3 over 2, that is opposite over hypotenuse. So like that, if it is cosine, depending on which angle you want to find it for, if it is cosine, let's find cos 30. Cos 30 will be adjacent. Adjacent is there, since the angle is adjacent over hypotenuse. That is cos 30 will be adjacent, which is root 3 over hypotenuse, root 2. So these are exact form of these trigonometric ratios of special angles. So if it is that of 45 degrees, so we use this right isosceles triangle. Also by Pythagoras, we can generate value for this hypotenuse, which is root 2. And from here, we can say tan 45 degrees. We obtain that as tan. It's either use this or use that. Opposite is 1, adjacent is 1, 1 over 1. And that is giving us 1. And if it is sine 45 degrees, we want to find as well. That's going to be sine is opposite over hypotenuse. That is 1 over root 2. So which when it is rationalized as well, we multiply both numerator and denominator by root 2. It's going to give us root 2 over 2. Thank you.
Good morning, everyone. My name is Ozo Victor Chimere. I'm a direct entry student, and my department is Mathematics Education, Module 2. Today, I'll be your personal mathematics tutor. And the topic that we have been dealing with is application of sort in trigonometry. But I'm going to be, the part I'm going to be teaching you this morning is the graph of cosine. So sorry, the graph of sine theta. And I made it easy by writing down the sum of the things that we are going to be needing. And what are those things? The first one is that we are going to be using the point 0, 90, 180, 270, and 350 in plotting the graph. And I also find out that when theta is 0, by the time we apply sine 0, we give you 1, 90 is 1, 0 is 0, 90 is 1, 180 is 0, 270 is negative 1, and 360 is 0. So we are going to use those points to plot the graph of this sine theta. Then I will describe to you what they are used and the things that are there. So the first part will be saying when theta is 0, it's also 0. When is 90 is positive 1. When is 180 is 0 again. And when it's 270 is negative 1. And when it's 360 is 0 again. Looking at it, the graph will go up like this to connect with this. Then it comes down to 180. It goes down to 270 and then comes up again like this. So if you look at the graph, if there are more, I want to continue, but the thing will continue like this. So important things to notice there is at the place at the turning point, the maximum point is known as amplitude. Is known as amplitude. That means the place the thing turns. So the amplitude of this particular one is positive 1. And if you look at it, it goes one up and it goes one down, negative 1, so the amplitude. And while you complete one cycle, it's called the period. So the period that it takes is sine theta to complete, sine theta to complete, as we are seeing it now, is 360. It takes sine theta 360 to complete one cycle. The up and down cycle is known as also one period. I believe I'm able to teach you how to plot sine theta and their different aspects of what they mean. And it can continue if you want to draw more than one period or one wavelength or one solution to infinity. It's like a wave. Thank you for actually being in this class. You are welcome, and I enjoyed the class with you.
Good day, students. My name is Andrew Abiodun Shola, in the Department of Mathematics Education, Module 2, Maths 3C. Today, we want to look at graph of cosine function. And on the graph, we'll be plotting this graph. And what will be the objective of the lesson? We want to look at how to interpret cosine graph. Just as you can see, we have the table of values. Now, these are the values of x from 0 to 90, 180, 270, and 360. Now, this pi here is representing a period which is 180 degree, and 2 pi is representing two periods, which is 360 degree. Just as we have here, pi over 2 give us 90. That is 180 divided by 2, giving us 90. Then when you continue like that, this is 180, this is 270, and we have the 360. So how do we plot the graph? Don't forget, this is representing y. Y is a function. Okay, so why this one is what our x? So it means that when x is 0, y is what? Y is 1. When x is 90, this is 90, y is what? 0. When x is 180, y is minus 1. So this is minus 1, then the conjunct here. When x is 270, y is 0. This is 270, and the meet here. When x is 360, y is 1. So we have 360 and 1, and the meet here. So now, how do we join them together? Now we have like this. So this is what we have. So what does this explain? At this peak here, this is the maximum, while this here is what? The minimum. So telling us that over here we have the aptitude, and here we have the minimum. Okay, so meaning that how do we interpret this oscillation? It means that a periodic wave that oscillates between the maximum and minimum value. That is, as it's increasing, is decreasing, increasing, and as well what? Decreasing. So that is what we call oscillatory movements. So this is the graph of cosine function. I believe I've been able to explain this part. Thank you.
Hello, good afternoon, everyone. My name is Abu Innocent Peter. I am your personal math tutor for today. Today, I shall be explaining how to use sine graph to solve simple trigonometrical ratio. For example, when you are given sine s equals to 0.5 and you are asked to look for your s, first of all, you need to know that in sine graph, which I have explained before, in sine graph, this x-axis represents your degree, while the y-axis is sine s. So when you are asked to look for s when sine s equals to 0.5, when you look at the graph very well, you will see that for sine s to equal 0.5, then s must always be 30 degree. When s is 30 degree, then sine s equals to 0.5. Thank you very much for today. In our next class, we'll talk more on this issue.